Hello, everyone. Welcome at our core protocol sync. We'll share updates from the team from last week and plans for the immediate future. And let's start today with Ivan.
Yeah, sure. Let me share screen. Yep, here it is. So basically, last week we migrated from the RocksDB to PartyDB. Yep. Also, that includes the migration itself, so that we could like migrate the old databases from the RocksDB to PartyDB. Basically, right now that includes like 2, 3 databases. Yeah. So basically, the thing is that we actually burn commitments instead of like migrating those, as they can be regenerated. Yeah, and as the other like database which actually has migration is this index hash to offsets database. Yeah, it basically just clones like each key and value to the PartyDB. Yeah, um, um, nothing weird there. So another thing which I was working on is the removal of the legacy multiplot. Farming, yeah. So basically, we just removed this file and migrated all the tests and etc. to the new single plot farm and single disk farms. Yeah, mainly to single disk farms, as for example, yeah. For example, in benchmarking beforehand, we used the legacy farming. Yeah, and right now we just spawn the single disk farm, and it also supports like different disks from the CLI for benchmarking purposes. Yeah, yeah, that's it on my end. Um, yeah, if you want, we can discuss the issue related to the party DB migration. Yeah, here right now, or like we can push it out of the recording.
Let's discuss that right now.
Oh, okay, yeah. So, but basically, I've been looking into that, and it seems, yeah, but basically the issue is not in the pre-allocation of the memory for the buffers or etc. So basically, it just exceeds out of memory, yeah, and the spiked usage of the memory for the parity DB. I guess parity DB is actually, as there are several of those, like it spikes to the 6 GB or something. Yeah, so I had suspicion that it might be related to like some of the commits to the database, as like PartyDB basically batches all of the inserts into the database with the commits, and we basically could have created the big commits, but it seems like that's not the issue. Also, yeah. Was looking a bit into the sources of the at least B-tree index database. Yeah, didn't find anything there right now. Yeah, so that's all of my input on this issue.
So first of all, memory allocators usually are not designed to minimize memory usage. They are optimized for performance, so they can use more memory than they actually need just to optimize things. So the first question would be, does the memory usage grow as you are syncing, or it only grows when you start recommitment? Like before it starts recommitment, is the memory usage high already?
I didn't check the sync scenario. I just migrated the old farmer to the new one and checked whether like migration is working, and it was working. I didn't exceed the memory. Yeah, everything's okay there. So I checked the recommitments. It exceeded like 2 GB, which was like our previous requirements for the RocksDB. So yeah, that was unfortunate. I moved the I basically added 2 more gigabytes. Like it has right now 4 GB, and basically exceeds like in some time after like recommitment is done or like partially done. So yeah.
Okay. And if you restart it after a commitment has successfully finished, after restart, does it use a lot of memory or not, or like is it growing over time?
I didn't check that. I think yeah. I guess no. Sorry, yeah. I didn't pay attention, but I guess the thing is that it didn't finish recommitments for like all of the plots. Yeah, I guess I can add like more RAM, and see.
Yeah,
like,
we just
better,
need to narrow it down a little bit. The only big difference I think that I can like think of right away is we were using RocksDB, and I'm not sure if it was set in the global allocator, but it might be the case. It was basically including gemalloc dependencies. And if that was set as global allocator, then we were using that for the whole application instead of the glibc provided. So we can try to introduce that again and see if it behaves better, if there is any difference. So that would be like the first step to try. I believe Polkadot already uses that in their like relay chain implementation. It's not enforced on the substrate level, but they are using it, and they were recommending for some reasons to other parachains. So that's what I would try. Otherwise, I would just report to ParityDB folks immediately and see what they have to say. It's definitely interesting behavior. It works,
Mm.
uses insane amount of RAM comparing to what we need to do. It feels like it stores the whole database because that database will be, or like the sum of the data we are storing will be about that size. Though it's mostly plot, which is like just a flat file. So it uses actually a lot more RAM than the sum of all databases combined if you were storing them in RAM. So it doesn't make any sense.
For the info on my like local setup, I just use like I just have 10 plots or something. Yeah, that's for 10 plots.
Yeah, and Substrate also uses ParityDB in our case for a long time, and there is no such problem. So maybe there is some kind of use case specific behavior.
Okay. I guess I can try the Jmalloc for now.
Yeah.
Yeah. Should we just like create tomorrow create a release with RocksDB instead of ParityDB for now, till we if we didn't discover like the issue of what's the cause of the issue.
Yeah. Let's discuss it separately.
Okay, thanks for going over that, guys. I'm just trying to make sure I'm following along here. So we're using ParityDB in lots of different places right now, but we're sure that it's related to the farmer's usage of ParityDB, not the substrate node's usage, right?
They're a separate executable. You can clearly see that that's the farmer.
Yeah. Okay. But then on the farmer, I didn't realize this. We're actually storing the plot files in ParityDB as well. We're not putting those.
No, plots are still flat files.
Okay, just not unrelated to ParityDB. Okay, so it's just the BST and then the different maps that we have are stored in ParityDB.
And the sum of all of those maps together on disk is smaller than 6 gigabytes.
Right. Okay, so we're not really sure if it's related to the initial plotting phase, the recommitment phase, or to the actual solve phase. We haven't really isolated what's causing this memory consumption right now.
Well, whatever happens during recommitment certainly helps. Whether it's reading from all of the things or writing to all of the things, but it certainly happens after you've already plotted and you just start recommitment. So you can probably test that because that's quicker. We don't have to like start from scratch again.
Okay, so it is related to recommitments. We have isolated it to that.
At least.
Okay. And did we test in like before we deployed this? Did we do any local testing of recommitments to see if it would affect it, Ivan?
I mean, everything works.
Yeah.
It's just high memory usage.
Yeah, everything is correct. Yeah.
So we don't check the memory usage or anything like that. We don't do any benchmarking or profiling as part of testing. Okay. So did we find out because users were just saying it was like crashing on their machines?
Not crashing. They were just complaining that it uses a lot of RAM.
Okay.
And it's also very often a function of how much RAM you have in total. So in some cases it's less, in some cases it's more. It just depends on how much you have on your machine. It seems like if you have less, it will actually use less, but not very little either way.
Didn't we actually extend the ParityDB API to support the range search that we're using for the things for commitments, or was that already there?
Searching for range. We actually extended it for the piece index hash to offset. Yeah, for the backwards iteration. Yeah.
Mhm. Okay. So this part that we're using for recommitments was already part of their code base. It's not nothing that we modified. Okay.
Yeah.
I'm just curious if maybe, it's really optimized for like the flat or more like the blockchain database side of things, and maybe something like RocksDB is actually much more optimized for like the recommitments and the searching.
Guys, like party folks, they also mentioned that like at least B3 index database is not like totally ready. It can use like way more memory or on the disk at least. They mentioned that, so that might be the issue. But yeah, I don't know yet.
I guess the summaries will do more testing, more experiments, so we figure out what's the root causes, and if we cannot solve it, we'll just migrate back to RocksDB, at least for those databases that we migrated over last time.
Okay. Okay, thanks for going through that, Ivan. That's all the questions I had.
Okay, let's transition to Shamil.
Okay. Last week I worked on the DSN v1 description. I finished 2 revisions of it, and I will probably continue with it this week.
And no pull request this time?
No coding last week.
That's unusual.
Shamil, could you just give a little bit more update for the group on on what that spec looks like right now, or what the revisions were?
Sure. Initially, I described multiple algorithms that we had in our DSN, like basic sync, object mappings, different request response protocols. I summarized all the knowledge that we have on this DSN in a single page, and Jeremiah created some questions related to the first version, and I added several more sections, like a high-level architecture overview, different protocol description, like interfaces and signatures for the request response protocols, and added a lot of additional information on the page. And I think it's ready for the additional review. I hope I answered your question.
Great. Yeah. And just going forward, Shamil, whenever we get a new update to that, let's just share it in the public chat and just let everybody know, so that everybody can come in and take a look at it, and we can have kind of a collaborative review, just like we do on the GitHub code.
Sure, I will do that right after our conversation here.
Great. Thanks. And I'll take a look at that. Okay. I guess regarding next steps, I'll review that, and then we can sync up and figure out what we need to do, and if we can start working on the V2 spec as well.
Okay.
Thanks for putting that together, Shamil.
Okay, then it's my turn. This one. Should be able to see it. So this one was merged 6 days ago, but we discussed it last time, I believe. So there is nothing new there to discuss. There was a preparation for Gemini 2a. First of all, when we are building the chain spec, several people already asked why there is a single boot node in the assets here. So if we go here, assets, raw spec. Yeah, okay. Basically, there is a Bootstrap node which is localhost, and I decided we can build it without that, so it's not confusing. It's not really helpful by default. And I've added the Gemini 2a spec, very similar to the spec we had for the pre-stress test network. Nothing really special, just some parameters. The major difference is, of course, the size of the network. So we have 10 gigabytes per max plot size, as we discussed. Otherwise, it's almost the same as Gemini 2b, 1b, and we can compile that. So when we are running the workflow for chain spec building, we actually have a different chain spec build, And as I just showed you, we have this new pre-release with the chain spec that we are using for testing purposes or like preparation purposes. We can see all of our nodes that we have so far on telemetry. They're just idling, waiting for people to join tomorrow during launch party. Otherwise, there was a small fix to the RocksDB migration. Basically, in RocksDB, you can specify different, I believe they're calling it columns. Maybe there's different terminology in RocksDB. And when we are writing migrations, when Iman was writing migrations, he didn't account for that. So when you are trying to open a database that had 2 columns with just one, which is the default, is the one, it just fails to open. So migration wasn't actually running properly. So that was a small fix to just open it with correct parameters. Otherwise, it's all the same. And then there was some cleanup for the legacy code. First of all, we had proxdb, which we don't need anymore. So I deleted that from dependencies and from migrations everywhere. And the other one was we had these few pre-stress test networks, and we didn't have a special handling for deleting their databases, so they were actually like stored. So I decided to add them alongside Gemini 1B. So when everyone who was testing that upgrades and wipes everything, they will get those deleted and not waste their space. So those are all of the changes we had in our repositories. There was one small pull request for the Polka.js apps to delete extra Gemini 1B endpoints. We just have one in Europe. And there will be another pull request today to add Gemini 2A. And there was some work which is not in pull requests that will result in a pull request probably today to add the actual full support for Gemini 2A, so we can build executables, container images, everything tomorrow, and have a launch party. Yeah, plan for this week is to ensure that our stress test launch is successful, and if there are any questions or issues, we'll try to resolve them as soon as possible, and hoping for the success there. That's a small update relatively to some of the others. Any questions about any of this?
Why are we doing 10 gigabyte max file size? I missed something.
That's part of the announcement. We are trying something different, and it's described there, the rationale. We're basically going for the participation and not necessarily about total space pledged. So we want as many people as possible to be able to participate.
Okay.
Yeah, if you read that document, Daria, that internal document we have on the Gemini 2 plan, it kind of describes the rationale for all that in there.
I think I did read it when you put it out, but I have already forgotten.
There are some updates there. You can check it again.
Yeah, the incentive model's changed again. Updated, revised.
Okay, I'll take another look then.
Okay, Daria, do you have anything you want to share today?
So on the consensus V2 spec, I have applied some of your suggestions that we've discussed in a meeting on Friday, and I think I have finished with the final plotting section, the proving and verification, just based on your document, which I might still be a little messy in the verification steps. But, and I think I'm missing the section on actually retrieving the information, like extracting the pieces. And I'm not sure if I can actually start writing it until we pin down the erasure coding commitments, because I feel like that's going to change significantly if we change that. So I'm not sure whether I should start on there or not.
I mean, the high-level algorithm should still be about the same. Just like functions can change.
Okay, then I will write down the, well, something else, and then we'll see about it on Wednesday.
Yeah, Dari, the archiving process where the chain history gets erasure coded and committed to is going to be the same way we described it before. It's just the way that archiving is done in a verifiable way using like data availability sampling like across the network. That's what we're still working out. But at the end of the day, it's going to achieve the same result. It's just not all going to happen on one node like it does right now. So from your point of view, from the specs point of view, it's kind of orthogonal.
Okay. Well, there were still some things that we haven't decided from the last time, is whether we are going to include the witness in the pieces or in the segment, or whether or stuff like that. But well, I'll see how much that actually matters at that stage.
Yeah, just assume that the piece witness, there will be a witness for each piece, which will be included inside it, like as part of the record, like we do right now, where we have like records that are compiled into pieces. But just those pieces will be much larger, and it will be a KZG versus a Merkle witness.
Okay.
But in terms of, I think there's still this open question about how we're going to generate the witnesses for the chunks as well. That we can just put a generic witness scheme and just say it's derived on demand. But that's one of the things we do need to sort out. But that's not going to like fundamentally change the spec. It's just a small detail, really.
Okay, then that's basically the only thing that's like completely missing is the retrieval of information, and then well, DSN sync as well is not there. Other stuff about plotting, auditing, proving, and verifying should be more or less done.
Wonderful.
Awesome. Looks like I'll have fun implementing all of that in a few weeks. Okay, anything else we need to discuss before we close the recording? Okay. Thanks everyone for watching, and we'll see you next week.